In this lesson we're going to look at geometric sequences, which are similar to the arithmetic sequences you've already been introduced to. So we'll take a look at some examples just so you can see how it works. Can you find the next term? 256 in this one. What about the next? Can you figure out in this sequence what the next term is? Should be -8. And finally, what do you think this one would be here? It would be 1/3. So if you're thinking about how do you do it, you're multiplying by a common value. So what do I mean exactly? Well, in the first series, that's times 4, times 4, times 4. So that's what the rule is here, is times it by 4. In this one, I'm timesing it by -1/2. Each time I move over, it's times -1/2. And that's how I got from 16 to -8, is I went times -1/2. And then finally, this one here is times 1/3, times 1/3, times 1/3. So that's the rule for each of these sequences. And when we multiply by a common value, we call those geometric sequences. This feature is super important. We call this the common ratio. And what you need to know about it is the ratio of successive terms is a constant. So it doesn't matter which ones I pick. 64 divided by 16 in this sequence is 4. So is 16 divided by 4. So is 4 divided by 1. Any term divided by its previous gives us the common ratio. So let's try it here with a couple. In this one, I'll just take the first two. So it'll be 1/2 divided by 2. So that's 1/4. So the common ratio is 1/4, and you can verify it. 2 times 1/4, that's 2/4, which is 1/2. So that got me to the second term. And if I times it by 1/4 again, then I get 1/8, which is the next term. Okay, so again, any two terms, I mean, we could take these two, but why would we want to work with those decimals when the easiest pair is probably those two? So in this case, the common ratio is -3/2. So now that we know a little bit about geometric sequences, let's try and apply this idea a little further. We're going to build up a formula to it. So I could ask you to do this, find the 30th term in this sequence, and you could just hit your calculator button a whole lot of times and hope that you get it right without making any mistakes, right? But somewhere along the way, if you push one button wrong or something didn't go in as planned, then everything's ruined for the rest of your calculation. So let's find a better strategy. We're going to write these terms out looking for a pattern. So first of all, we have to find the common ratio in order to work with this sequence. So right now, I'll take the first two. Oops, pen's a little sticky. So it's 5/2. So what I'm going to do then is I'm going to go and multiply by 5/2 to get the next term. So 25 times 5/2, and I'll be at 62.5. Then I multiply by 5/2, and I'm at 156.25. And this time, I have 390.625. So those numbers aren't as important to us this time around as we are trying to build up this pattern. But if you think about it, the first term, we're still going to call it A like we did before. To get there, I had to apply the common ratio one time. So it went A times R. To get from 10 to 25, I had to do it again. So now I've gone 2 times. A R squared. And then to get from 25 to 62.5, that's 3 times. So A R cubed. And we'll continue this. So that hopefully you can see the pattern. you'll notice that the term number is 6 and the exponent is 5. Term number is 5 and the exponent is 4. So in each of these cases, the term number, the exponent is 1 less than the term number. So if I did this pattern all the way up to 30, it would be the first term, and then apply the common ratio 29 times to get there. And that's because there's 29 steps on the way to 30 if you're already starting at 1. So now it would be 4 times the common ratio, 29th exponent. And you might have expected it, but it's a fairly large number, so I'm going to round it. It's going to be 1.388 times 10 to the 12. So we're going to take this pattern and now we're going to put it into a formula. So Tn is what we call the nth term. Just like we would up here, we call this the 30th term, right? So when we say nth term, we mean any term you're looking for. A is the first term in the sequence. R is the common ratio. And n is the term number. So we can put together a new formula. Tn is AR to the n minus 1. So this is the formula that we're going to work with today for geometric sequences. So what is the 12th term in the following geometric sequence? So I'm looking for 12th term, so I need AR11. That'll be 6. And the common ratio, I'll use those two. 18 divided by 6 is 3. So it'll be 3 to the 11th. And that ends up being 1,062,882. Okay, so in the other sequence, I'll pick these two this time to work with. My common ratio is 24 divided by 36. And I know that both of those divide into 12, so I can call this 2/3 when I reduce it. So term 12 is the first term. Common ratio goes 11 times. And in this case, it'll be 81 times 2/3 to the 11. And this one's got quite a few decimals, but I guess I'll write them all out for you. Yeah, we'd probably likely round it if we were doing this. Maybe your textbook answers would be rounded too. Okay. So the trickiest thing that you're going to have to do is reconstruct a sequence from two terms. So the first time what I'm going to do is I'll show you the strategy. I know that term 2 is 28. And I also know that 28 is the common ratio times AR applied one time. I also know that term 5 is 1792, which is the common ratio applied 4 times to the first term. So if I take their ratio, 1792 divided by 28, that means I'm going to have to use AR to the 4 and AR to the 1 for the other side of my equation. Right? So 28 is AR to the 1, just like it is here. And then 1792, AR to the 4. So everybody is matching back up. Now the reason I wanted to do this was that division is going to get rid of the first term for me, and then I can use my exponent laws here. It's just going to become r cubed. So I'm going to have 1792 over 28 is equal to r cubed. That's going to be 64. So the common ratio is 4. Now that I have my common ratio, I can use it to figure out what was the first term. You could do it in either equation. I tend to pick the ones with the smallest exponent though. So this is going to be 28 is AR to the first, and we just found out that the common ratio is 4. So now I can solve for the first term. The first term is 7. So putting them together then, I know that the term formula is going to be 7 times 4 to the n minus 1. So I can find any term now just from starting at these two. Okay, so this next one is a little trickier, and you'll see what I mean once we get into it. Most students get about, they get the whole way through it, but they've forgotten something carelessly, so we'll see if you can figure it out as we go. Okay, so again, 1/4 is going to be AR to the 7, and I have 64 then must be AR cubed. So I'm going to put my highest exponent on top so that when I use my equation, the R can stay on the top of the fractions. So that'll give me 1/4 over 64 is AR7 over AR cubed. So A is gone, and this leaves me with R to the 4. So 1 over 256 equals R to the 4. And now you either need the 4th root of 1 over 256, if you're fortunate enough to have that button on your calculator, or 1 over 256, you can raise it to the exponent 1 over 4. So this tells me that the common ratio was 1/4. So did you catch the careless mistake that I made? Lots of people forget this one, but when you have an even exponent, you have to do both positive and negative. Because when I raise this quarter to the 4th, it gives me 1 over 256. But I could also do negative a quarter, because the 4th exponent is going to make it positive when it comes back out as 1 over 256. So that's the tricky part about this one, was that there's actually going to be two possible answers. One when the common ratio is a quarter, and one when it's negative a quarter. So let's take a look at the first one, if R equals a quarter. So I'm going to use my equation, and it could be either one, but I tend to pick the smallest exponent. So 64 is AR cubed. So 64 is A and 1/4 cubed. So 64 is A times 1 over 64. And 4096 is going to be the first term. So that gives me a term formula of 4096 and 1/4 to the n minus 1. So in the second scenario, the common ratio is negative a quarter. So I'm going to use negative a quarter this time for the common ratio. So I'll have 64 is A times negative 1 over 64. And that means I'll have negative 4096 for my first term. So the common ratio then is going to be negative 4096. Sorry, not the common ratio, but the term formula is going to look like this. Okay, so in this one there's two possible answers because we have two possible common ratios.